Ladies and gentlemen, welcome to my shop. My name is Keith. I'm your host. Let's start off with the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. On with the show. Today we're starting a new project, and this is one of the projects that we've been really anxious to get that lathe back together, because we're going to have to turn a pretty good sized diameter, and I'd like to do that lathe versus the Rutland. This is an attachment for this motor, and a hexagon drive comes out the end of this attachment here, and there's a port over here on this side that the hoses come out. The hose is out here. So this whole pattern has got to be in a certain arrangement here, and we've jotted that down. Basically, we have alignment going up and down a vertical line here. This has got some bends in it. We're going to have to do some straightening out in here. These pins won't come out freely because the thing is so racked. So we're going to be taking a look at that as well. But right now, we've got to duplicate a piece of material to make a new ring to bolt that pump into this housing, and we're going to replace that ring itself. Those threaded holes all the way around there, every one of them is stripped out. So we got replacement and repair. And on the table, we have a piece of material now that's going to rough out for the ring that's going to go around for this. This is a piece of 3/4 inch plate. We've already drawn the part out on our screen there. Came in and mapped out where our pierce is going to be. Come down here, marked where our pierce is relationship to that. We marked the grate all the way around on the part. We took it in there, drilled it out on the big drill press, came back in, and we set it back up, and we were just verifying that that's where it was at. And we're going to clamp on a ground here, and our lines and everything else still look pretty darn good right there. I like that. And we're going to put a little bit of draft blocking here. That's all I use these. You see me throw these on every once in a while when I'm doing something on the machine here, and this is just to cut the draft down so it's working where the cut is. Okay, we're making sure that the machine is 100% reset. We're going to come over to our pierce spot here, just double check that. The outside pierce is going to be like right here. Alright, that looks good. I'm going to add some draft here. All right, let's give that a shot. Water plate. Cutting it at 8 inches a minute. So 60 amp torque. Alright, that looks pretty decent. We're going to let that cool down a little bit, and we're going to start taking apart the fixture there. Okay, let's see if we can knock out some of these bolts and pins to relieve the pressure. There we go. Okay, now we can probably pull this piece out here. Yep. All right. All right. This top piece right here, we're gonna have to straighten out. We can do some creative parallels and then press that down with the press. All right, we're gonna pull this other piece out of here. A little stuck in there, huh? A little rusty. Okay. We want to go ahead and measure up this hole pattern here and make a record of it, because we're going to turn and bore that ring to represent this ring right here, and we're going to have to put this hole pattern in it, locate it on here, and then re-weld it. We're going to set this up, and we're going to take a torch, and we're going to cut that weld and remove that piece off of the end of the barrel. Alright, we mounted it up in our 3-jaw, looks pretty good. Now we need to get our cutter out to the outside diameter on this part, so we're going to set it square. By eyeball. That looks good. All right. Feels pretty weird not having any play in here. Okay, we're gonna do like 50 thousandths per revolution. Let's come up with a medium feed rate. We'll get the feel of this. Sounds like a pretty hard spot in there. Let's see. Yeah, I think it's just the way it come over the top of that. Insert's not broken, maybe a little dull. Alright, we're going to check our dimensions here. Alright, we got quite a ways to go. It's supposed to be like 9.5 on the outside, open air measurement, so we're at 900. So basically we're going to take another couple hundred off each side. That's a bit fast. Okay. I'm going to go for another 50. Okay, we're gonna make sure that's tight. We're gonna go ahead and index our insert here just to check it. I blew it off. It doesn't look bad at all. Maybe just tightening that up a little bit is going to be fine. See what we got. I call that harmonics. Got to open this bore up pretty good, and I know that we're going to be out past the diameter of this inside jaw. I flipped these around and I'm grabbed on the outside now. So what we're going to do is take and put a shim. I got these 5/16 tool bits, these virgin tool bits, and I'm going to put them behind the jaws like that, and you got to open it up a little bit more. Okay. And I got these two, so I'm going to put one in here, then one behind there, and then I'm going to go ahead and tighten this up. Alright, now I should be able to pull these out of here so they don't go flying. Now we can really cinch it down. Let's spin it up and see what we got. Okay, I do see a little bit of walking back and forth. Even on the back side, this front side, I see a little bit more. So what we're going to do is take our indicator, and then we can adjust it here. But you know what's funny is it's okay, we got okay, we're going to say 0 on that jaw. We're about +2 there and +2 there. So really it's kind of a little warp in the plate. Alright, so now our decision is to go ahead and leave it there. We can take a skim on this surface right here to clean it. But we're going to go ahead and bore it out first. Okay, we're going to touch on the face. There we go. Set our travel dial 0, just so we have that marked. Okay, and now we're going to come out. We'll come out an extra 50 thousandths or so. Now this opens up to about, I think, 7.375, 7 3/8, I believe. So we have a ways to go. All right, we'll call that another 50 thousandths per side. Chip was coming around the camera. Yeah, there we go. All right, we brought our ring in here. We've machined it to where it had like 15 thousandths, 20 thousandths clearance over this diameter right here. Slipped it up on here. The reason why we went for clearance is this has paint on it, it has rust, and this flange right here has just a little idiosyncrasy on it. We're clamped up in here. We know that this is 16 holes in here. My super spacer and a couple other things are gauged on 24 increments, so the 16 is not going to fit in there. Plus, this has got 2 flats on it, and 6 of the holes aren't even used. So we're gonna transfer punch this, and we're gonna drill and tap each hole individually, and then this ring will be ready to weld on here once we've removed this one. We marked center line for this hole pattern in here because this is the window right here that these hydraulic lines right here and here come through. So this hole right here is really that hole right there. This transfer punch fits nice and snug, so we're confident we got good center punches where those holes need to be. All right, we're going to drop that down and drill and tap it. We come out here to check our holes one more time. Now, the customer had stuck a couple bolts into the motor when they dropped it off. And I measured these in the 10 millimeter, 1.5 lead, something like that. It's not what these holes originally are. These holes are 3/8 national course. And they don't go all the way through because there's a weld back here. This ring gets welded to this pipe all the way around. So those holes have got to be drilled and tapped out blind. So I'm figuring out the standard bolt, which I believe is 3/8 by 1.5 inches overall on the length, how far to drill and tap down through there, and whether they run a lock washer or not when they go through the motor itself. That flange will come up against the back side, and this hex auger connection hangs out this side, and the plumbing and everything else is inside here. Now, I hold one of these in the flange here, and I put the washer just so that it's underneath there so I can get the right thickness right here. And I have a 1/2 inch of thread engagement. All right, and that's more than enough for a 3/8 bolt, because a bolt strength in length is no stronger than its width. So a full 3/8 of an inch contact of threads is minimum. Anything after that is extra, all right, required. So I'm going to go ahead and drill and bottom tap these to the bottom of the ring that we've got on the drill press right now, or the Bridgeport, and leave the back solid to take that weld so that no splatter will go through the holes. There's not going to be a strong weld, weak weld, strong weld, weak weld. It'll be continuous, a real nice good weld on there. All right, so we just came back out here and we wanted to verify what we're going to be doing in there. We're all set up in here, and our nice center punched hole pattern ready to go. We sharpened up a 5/16 drill, which is the tap size for 3/8 national course. We came over to the table, and also too, I wanted to point out, we put this drill bit in the chuck all the way up. It's not going to drift. Okay, and we tighten it down so we know its location is not going to change. We come down and we touch our table without the drill bit moving, and we set 0. So we know that that drill point is 0 with this, and we're going to come over here. No matter what, we always practice, and if we're going to drill on the table with nothing, then we make sure that our drill is going into that slot, and we never put one of them marks in the surface out here. So now we can come in here and we're going to drill down through each one of those. But we came down, we set it at 0, we brought it up. I'm going to bring it up 60,000, a 1/16 of an inch. Reset 0 on my travel. All right, so now we can come down. We're going to come down to 0 each time. We could also put a hard stop, which I don't. Right now, in Buffy's collection is my clamp on stop, which is good as well. Or we could bring the table all the way down and we can run the quill stop nut, the standard nut that comes with the lathe. We can run all of that. But we have a digital dial on our Bridgeport, and we can go ahead and come down to our 0. All right, we're drilling these freely. Whenever I transfer punch a hole pattern and then come over and drill it, I really like the Bridgeport is the best for this, because you can let your part float on here. It's easy to center up that drill and that center punch mark. Even with a little bit of oil on it, it still locates and brings it, slides it right in there. This is on this heft of part. Really handy. Two nice chips coming out of those flutes. I made a test drill on a part, just making sure that I was really tight on my tolerances, because I want to make sure that these threads in this are as strong as they possibly can be. And here we come. We're coming up to, I can feel an ease up on the bottom, so I'm going to check this out. Okay, no dimple, but it sure felt like maybe it was mentally that I'm getting that close to the bottom. And let me see, okay, 2,000, 3,000. Okay, we come down to our 0. We verified we're not going through. We're going to run through the rest of these now. I like using the mill table for supporting and holding things that I need to tap out by hand, or fit, wrench, hold, take apart. Sometimes you got to hold something steady and you got to have your hands free for a little punch and a little hammer action, something like that. Mill tables, my most favorite is HBM tables. They're huge and give you a lot of area to work with. Anyhow, I made up a tap guide, and this is a 3-fluted gun style tap. The gun is just the way the flute pushes the chip down in, but it's a 3-fluted tap, and they're much stronger, and I use them all the time. Now, we're not going to be putting threads all the way to the bottom with this tap. I'll have to work on use another tap, and it happens to be a homemade tap. I'm using a tap guide, which is just a piece of gear rack that I've drilled out nice and true and running there with a nice clearance for my tap to pass down through there. And it really kind of keeps me straight up and down instead of guessing where this is all at right here. And it's such a short throw of threads that we're putting into this piece, I want to make sure that I'm as straight as possible without walking all over the place. I was able to get a little bit more in that one than I was the first one there, so maybe I just falsely stopped on the first one. Let's actually see how many I got on the second one here. Alright, there's a little triangle right there. 1, 2, 3, 4, 5, 5 1/4 threads. Okay. Put both hands on that tap, Mr. Fenner. Much better. Okay. Okay, these two taps are the same tap. It's just that I've taken this and ground the flat off to where it can back down in here where I have the full diameter of the cutting edges. I put it in the Leslie sharpener and gave each of these 3 flutes an equal grind on it with a little bit of relief off of it. And then I took the face, the normal gun tap face, and kissed that on the grinder. I want to give that a try for bottoming. I want to go down in there now and clean out the threads in the bottom as far as I can go. So let's see if this thing actually works. Okay, I'm gonna measure. This is 1 5/8 from the edge of the tap holder there. Okay, let's put a 1/2 inch of threads down in there. To 100. I might be able to grind a little bit off at the very end of it. Because I think this is like touching down in here on the drill point, maybe. That's 1 inch there. I gotta get my wrench to see if I can tighten it down any farther. Okay, I get 9 on the flange, and a lock washer is 101 or 105 thousandths. So that works right there. But I'm gonna go touch that off on the grinder on the end there, and we'll see if we can pick up another 50 thousandths, and I'd be really, really happy with that. Okay, I ground that down about the amount that I was shooting for, or as much as I could get, I should say. And let's see what we got now. Okay. I think I got 3/4 of a turn, which might just be a total amount. I'm just looking for clearance underneath our threads when I know this thing is totally 100% tight. Okay, that's bottomed out. Bottomed out at 900. All right, so it's bottomed out at the thickness of the flange, and we have 100 thousandths for the lock washer. That's it. happy with my whole situation right here. Okay, let's tap the rest of these out. And if my tap lasts through 10 holes without having to be redressed, we did a good job on the grind. I spoke a little soon. I just broke a flute. Okay, let's dress it. This one here, I held it in my tap handle and I hand shaped the entire thing over by hand on the grinder. This time, see, on the drill sharpener, I think I broke the back edge too sharp, made the tooth fragile. So here I came in and I just barely ground on the back side so that it had clearance as far as this coming around and cutting this way, but not dropping off, so I didn't, you know, I'm trying to keep the strength into the tool, just like a shaper tool. Same principle. Okay, now we'll go back down into that hole. We're going to see how we fare here. And the story will be, looks like I got them the same depth. The story will be screwing this in and having that 1/900 underneath the head here, and I mean 900, and I got like 925. $900. Okay, back on the road again. We're probably gonna have to clear it out a little bit, because when you go down against the bottom, if you get one little chip underneath the tap, it's gonna hold it from going all the way down in. But I will stop and I will test and I will measure each and every one of these. It feels like it cuts good when I can feel that it's cutting. All right, I believe we're all set and ready to go. Little chippy stuck on there, I guess, huh? All right, ready to weld on. See, now look, that starting tap put the little dimples in there, because those weren't in there just a minute ago. That's how close we are to the back side. Okay, this is the whole reason I put these ugly boots on today. Yeah, usually I like wearing my other shoes. They're a little more comfortable. All right, we're setting up. We're using the gas torch. One, I have a lot of control with it, and I can get in there, and I like how I can see the area of the material I'm removing and the material that I want to leave. And I went ahead and I put the steel down on the floor so it'll catch the molten dropping. Okay, let's see how we're doing here. Yes, I could plasma cut this. But I love the control that I have with the torch. I'm cutting out a little area here so I can see how far I actually need to come into it. Alright. And I can see that split line right there. Very nice. Okay. The whole piece is like wanting to come off of there. A little tiny bit over here. There we go. There's the ring face, nice and smooth there, and we feel it's the same underneath there. We're going to leave this hanging here because we're going to grind most of it. Let the sparks go down there, and then we're going to get the thing up on the table, and we'll start setting up the ring on there to weld that on. It was a little too hard for that thing to be swinging there and for me to get in there, so we're going to lay this down right here, and we're going to go ahead and grind this up. This face is pristine. Alright, that was really kind of fast to grind that off, and this face right here, I'm just hitting with the sander. Alright, that was just a saw cut across here, so it's not like it was faced. That's how crude these things were made to start with, and basically all it is holding that flange, and we did a fine job on that flange. Okay, we're going to set the pump up, set the flange up, bolt the pump to the flange, and then we're going to set this in place so that we make sure our ports for our hydraulic are lined up, and we're going to tack it, break it apart, and then weld it. Okay, we're not trying to torque them, we just want to make sure they all go in there. Alright, we're bringing, this is the two ports right here that the hoses have to come out of the housing here. We're going to take the housing, we're going to set it down over this. We're going to wipe the oil off of here and the grease off of here. One, because if I grab a hold of it with my welding gloves get grease or oil on them. It kind of gets me a little upset. Okay. Here's our center line. We put the punch marks to line up with that bolt right there. And we're also looking in here at our ports. And it's accessible right there right now. So that looks good. Now we're going to take our scale. And because this can flex around, there's plenty of room inside here. So we're just going to make sure that it's equal on the outside here. About a ½ an inch. Looks good. Like that. Looks good. I don't know why they cut into here or cut into here like they thought they were going to do something different. All right, we're going to go ahead and tack it up right there. We put a little C-clamp on here because we want to grab a hold of this ring, which is one of the two pieces we're welding together. We don't want to leave it clamped onto the table because then it can arc through the shaft, up through the bearings, and into the housing, and really get into a really ugly ordeal here. So we're going to go ahead and clamp right onto the clamp itself. The current only has to go from here to there. Small tack, we'll get one on the other side. All right, final assembly. I went around and I screwed up a bolt in every one. This hole here had a booger in it. I had to put the tap back in that. I just Scotch-Brited the top so it's nice and smooth. And I got my fasteners ready. We're gonna lower this thing down in there. I've got it steady right here on one of my parallels for my hydraulic press. And the opening for the hydraulics is on that side there. Don't get your fingers in there, buddy. All right. Rotate it in that position. There we go. Probably the weld here has pulled the flange back slightly around the outside, but it is tight in there. You often wonder how much those torques. You know, those things are pretty stout. Pretty close fit there. All right, now this one here goes in here, and it was held in by this bolt. We know none of this saw any never sees here, that's for sure. Okay. And we slotted this thing here so that that adjustment could come up here, and I think that'll work fine for them. All right, and that ear goes together really nice since this was pushed down. I think they're going to be real happy with that. And they had 2 other bolts in there, something like that, when they brought it in. There we go. Ready to call the customer. All right, nothing real fancy. We did have a pretty good challenge on putting those blind holes in that ring, and the fun of taking the old ring off. Those things kind of fell right into place there. This is clean. It's kind of crude, but we were able to manage, and I think they got exactly what they need to have here to get her done. So until next time, get her done.